share this video with you again. First, software application is becoming more and more complex. You can see that it starts with the monolith architecture, everything is in a single box. And then we have client server in 2000, where internet started explode. And then we have service-oriented architecture. So you can see there are multiple services and software, there are more components involved. And as of today, microservices is the most popular software architecture, right? So with cloud native, you have Kubernetes, you have a lot of containers, and the services are calling in each other, right? So that is the software is becoming more and more complex. So this is a real challenge for the observability, right? In the field of software engineer and system monitoring, observability refers to the ability to understand and gain insight in the behavior and the performance of a complex system, right? You can see the software system is a complex system, right? So there are some complex, basic, fundamental stuff we call the pillars of the observability, say metrics, logs, and traces. These are three pillars of the observabilities. So let's take a look how we can unlock the challenges, right? How we can attack those challenges. The first is the complexity, right? So the environment is dynamic environment. So that means we need to monitor microservices and containers. And compared to the traditional software, the containers are actually prone to change, right? Some containers are created and die and restart. So it's very complex and dynamic. And second, like the big data, right? Because there's the microservice architecture, we have huge amount of metrics, huge amount of logs, and so the volumes, velocity, and variety of data is really a challenge. Also, it's hard to quantify the business impact of observability, right? We all say observability is super important, but it's hard to quantify. So how important it is actually is pretty important. So today I'm going to share about something about the Timeplus cloud, right? So how we actually leverage Timeplus, the capability of Timeplus streaming monitoring to monitor the Timeplus itself. So this is the architecture of the Timeplus cloud. So basically, it is running on the AWS. So the physical layer, we have AWS, we have EC2, we have S3, we have all the physical resources. And then we actually running on AWS EKS, where we have Kubernetes, and we have volumes, we have containers, so we have pods. So everything is virtualized. And then on this virtualized layer, we have our application stuff, right? We have different workspaces for each of cloud customers, and each workspace has its dedicated volume storage, the database core. And then we have shared API services. Of course, we have several different deployment, different environment for example, for different regions. Okay, so but Timeplus itself is a real-time streaming and analytic platform. So but generally it's just a modern software application. It's developed in like Microsoft architecture has several different components running in containers, leverage all the cloud native features. So for example, first it's running on AWS cloud as a SaaS offering. So there's a lot of container built on top of container technologies using Kubernetes. It has multiple environments, so there's a testing environment, staging environment, and production environment. And also we have multiple layers. For example, we have, like mentioned, there's API layer, front-end layer, we have the database core layer, so multiple layers. And in our case, we also both contain stateful and stateless components. For example, the API service does not have any state, it's just stateless. So we can easily duplicate or replicate a lot of API instance. But for the backend database is actually stateful, right? It's where the data is. So it's the stateful application is actually way more complex to manage. Okay, So this is a observability architecture for the data architecture for the observability. So it's actually, very common in any like data analytics system, right? We have data source, we collect data from source, we save those data to the storage, and we do some data queries, and then we can visualize these data for monitoring, or we can send an alert in case the query return some errors that need to be taken action. They're actually talking about open source community. Actually, there's a lot of tools that can support us do these observabilities. Like we have a lot of data collectors like Vector, Beats, Airbytes, Logstash, Fluentd. And also for the data storage and query, we have Prometheus, we have Elasticsearch, or you have Grafana and Kibana for the visualization and other stuff, right? So these are the old. Also, there's a lot of commercial product you can use like Splunk, New Relic, Datadog, and other stuff. So, but in our case, as we are streaming data analytics platform, we actually eat our own dog food. So this is the architecture of our own observability for Timeplus Cloud. Right? So first we have Kubernetes cluster as a data source. So all the data is actually from Kubernetes. So we do the data collection pipeline leverage the vector. So the vector will collect all the metrics and logs from Kubernetes cluster and send to the Confluent Kafka topic. Right? We have two topics, one for logs and one for metrics. And then we actually have a dedicated workspace, Timeplus workspace that monitor those logs and metrics. So this is our internal, we call the monitor workspace we created two streams based on these Kafka topics. One called Kubernetes logs, and there's a Kubernetes metrics. So we have two streams, and we can run real-time streaming analytics on these two streams. So to monitor what's happening with our cluster. So why in this sector we are using Kafka or Confluent Cloud? So it does bring some benefits. First is flexibility. That means we can decoupling the data producer, which is the logs and metrics, and the consumer, which here is the Timeplus. Because in this case actually we can have other consumer that consume these Kubernetes logs and metrics. So that's a benefit. Next one is real time. Kafka provide a low latency data transportation. And there's a back pressure. For example, if Timeplus is handling a slow, or Timeplus has a temporary errors that it stopped processing, we actually back pressure all the data through the Kafka to the because Kafka is effectively just a caching layer. Of course, it's scalable and high available. So a true story I'm going to share is a real case that we are running. So our disk space is low because we do have a lot of logs and metrics sending to our monitor workspace. So on that specific workspace, the disk is becoming low, and then because there's very few disk left, there's no space left. So a protection mechanism has triggered, so all the logs data and metrics data cannot be ingested. Because our Timeplus just reject to ingest any more data because there's no space. And that means in a 3 hours period of time, all the logs and metrics are not ingested into Timeplus. But that is fun because in this period of time, actually all the data is still in the Kafka. And because we reading Kafka has the offset mechanism, so after we adding more spaces, our data source will pulling the data again from the Kafka source. So there's no data loss. So everything back to normal. So with this data cache in Kafka, there's no data loss. We fixed the issues and all the data was coming back to Timeplus. So why streaming database? Like I mentioned, there's a lot of options you can use. There's an open source option, there's commercial options. Why using streaming database? So the streaming database is actually designed to handle and manage continuous data flow, right? So that means as soon as your data generated, it's being processed and analysis in real time. So in this case, once you have a new metrics or new logs generated, actually the streaming query can immediately emit the analytic result to the downstream, either it's visualizations or alerts, and then we can take actions. So it gives you the real-time insight, the monitor system behavior as soon as something happens, right? For example, the CPU is super high, or the previous case, the space is super low. And low latency is super fast. If you do care, want to take immediate action, the latency is super low in this case, like a millisecond latency. And also we can do some context even processing. For example, if you're monitoring some specific system behaviors, like even A followed by even a B, so we can actually create such sophisticated rules in the streaming processing. So there are a lot of stream databases today. For example, other than Timeplus Proton, there's like Rising Wave, Materialize, and SQDB, right? SQDB. Okay. So now let's take a look at the Timeplus streaming database we call Proton. Proton is actually an open source streaming database, right? So this is the high level architecture of Proton. So you can see actually fundamentally it has two storage processing. So one is streaming storage, it's just a append-only log, and the other is actually historical storage. It's actually built based on the ClearHouse, right? Why are we building architecture something like this with two storage? So actually, when we talk about real time, there are actually two directions you can attack this problem, right? The first one is actually you can scan the data as fast as possible. So that's what those OLAP database working like. So for the for the OLAP database, right, the column database, it can skip a lot of data very efficient, because the column database can help you to effectively scan the data, skip a lot of data, so to find what you want, right? And there's some other optimization for sure. But the limitation is actually for the column database, for this OLAP database, the data ingest is usually not in real time, right? Because when the new data is coming, it has to take some time to make this new data available for search, because usually the database will need to create like a index or other data structure to make this data available. So all these data are actually not in the new data is actually not immediately available to be searched. And the other one is actually the streaming processing. Right? The streaming processing, we process data in incremental way. Once there's new data, and we will process it immediately and give you a result, which sounds pretty good, sounds really real time. But these kind of architecture, like streaming processing, actually has a limitation to scan the historical data, because in most of the analytics, you actually need both historical data and real-time data to do the analysis, right? You sometimes only the new data is not enough. You need to draw in the historical data to get more insight. So in such case, most of the streaming processing architecture is actually built on top of some, like the Kafka, the append-only log system. That means the new data is coming, you can get it in super fast. But that also means when you scan the old data, there's no way you can skip any of this data. You have to read from the beginning and read from everything from scratch. So that means when you're handling historical data using streaming processing, it's actually not very efficient. Right? So that's why Proton has these two systems that unify or fusion these two systems, the streaming system and the historical system, and with unified SQL processing to give you the real-time result. So everything you see in this architecture actually is a single binary. That means the historical part is built on top of ClearHouse, has all the function from ClearHouse, and the streaming part is adding to that. We have streaming and historical, and everything in a single box as a single binary. So okay, that's the architecture of Proton. And here, let's take a look how this streaming SQL looks like. So the first pattern we call the streaming tail, right? If you select start from this log stream, it's actually show you, give you all the new data, right? The stream process pushing all the new data to you. It's actually unbounded query. So that means every time there's new logs, the data is coming to you. And also we have this historical query. If you add a table function to the logs, you just run, this is just the regular database query, right? You just like take a snapshot of all the logs and get the 10 record of this logs. And then we have aggregation. The global aggregation means start counting my logs. Every time there's new logs coming, we give you the new count. And then we have window aggregation, which is pretty popular in the stream processing. We split data into a small tumble, a humble window. And also because it's stream processing, you need to handle late event, and we can do the time travel. In this context, the time travel actually means we can go back to the stream and start processing. Of course, there's a lot of other drawing features like streaming drawing. You can join stream to stream or stream to table. There's a lot of that stuff. Okay, this is a dashboard of the Timeplus, the monitor system we are using. So probably we can do a quick demo here. Okay, let me switch to a quick demo here. So I'm going to log into our the Timeplus system, and there's our monitor system. This is actually the Timeplus UI. So demo, just select everything from Kubernetes logs. And you see the logs is coming in real time. The new logs is coming. Similarly, we can query the metrics. So this metrics as well. So we can take a look at this metrics. See, this matrix is actually some the tags, the values. This specific matrix is network like a transmit packet drop total. So there are a lot of metrics we are monitoring for sure. And like I mentioned, this is the streaming tail, but most of the cases it's just the starting point of exploration. You actually can, like I mentioned, we can add a count. This is the global aggregation. And if I run this, it actually returns the count of metrics in real time, say 1,300 and 2,300 something. So the new count will push to the users. This is global aggregation, and of course there's a lot of others. And let's take a quick look at those dashboard. We do have there's some. Let me switch to the observability because dashboard is in another workspace. So let's take a look at some of those dashboards. This is the one dashboard we monitor some specific sync source. There's no data. Probably we can monitor for example our API server. This one. This is the we monitor all the metrics and like total queries, total data size, something. Okay, so and yeah, that's a quick demo. So let's go back to the stats. So you can see we actually created several demo of different like metrics. We can monitor actually API calls, sync source, our own business object. Or we can monitor the low-level infrastructure, like CPU, memory stuff. Also, in the next demo, actually we create an alert. So in this case, actually we want to monitor if some of this, for example, I have two IoT devices are sending data to Kafka, right? We want to monitor whether this stream has data coming. In case one of the stream is down, we want to be notified that immediately that one of the streams is not generating data, right? So in this case, we can run this query. So this server part, we select everything from this IoT, and then we create a tumble window, and we actually can check the EPS. Say there's a lag function here, right? So the tumble window, 1 second tumble window actually calculating the EPS from these two streams. And once the EPS, the lag function give the previous EPS, the inner stream, right? So that previous EPS minus EPS, we got a change of the EPS. Once the EPS dropped like 20%, we can trigger an alert. So this is pretty powerful in streaming processing because you can easily calculate or monitor the change of your stream. Okay, so that's most of the top content I'm going to share today. And let's go back to these challenges and see how we solved those challenges. First, the complex environment. So the real-time stream analytics can provide rapid response and insight. So this can help you manage those complexity because we monitor this in real time. And also actually leverage Kafka Confluent, right? Leverage Kafka, we can easily handle the large volume and fast changing data because leverage Kafka, we can like I mentioned, right? All the data can be scalable, can be transferred to Timeplus in a scalable way. Last, like I mentioned, we created this dashboard that gives you the cross-layer KPI and metrics. So that means we show not only the low-level CPU metrics, but the business value of your platform, of your monitor. So that can help us to quantify the business impact. Okay. And thanks for watching this session. And if you all the demo I showed today is actually built on top of this open source database called Proton. If you want to do some monitoring by yourself, you probably can consider Proton as a good monitoring tool. Thank you.